How are you, my friends? In this video, I'm presenting 6 old exams questions related to ellipses as a conic section from lecture 38 of the pre-calculus course. Question number 1 is easy. Graph the ellipse 4x squared is equal to 64 minus y squared, and then find the coordinates of the two foci, the domain and the range. Clearly, we have to rearrange the equation. So we divide by 64. So we get x squared over 16 plus y squared over 64 is equal to 1. The biggest number in the ellipse always is a squared, which is 64, and b squared is 16. Now, vertical measure x is here because the bigger number is under the y. For psi, we can use the formula c squared is equal to a squared minus b squared. So c squared will be 48, c will be plus or minus 4 square root of 3. So they are f and f prime. These are the foci. Now the domain and the range. The domain, if the center is 0, 0, to find the domain of the ellipse, find x-intercept. So it will be from minus 4 to 4. If the center is 0, 0, to find the range, y-intercept, let x equal to 0. So the range will be minus 8 to 8. Question number 2 is nice. We need to find the eccentricity of the ellipse. The foci is given f1 and f2 and passing through the point 3, 1. So given the foci f1 and f2, we know that 2c is the distance between the two foci. So we can put 2c is equal to the distance 5 minus 1 absolute value. So c will be 2. Leave it now. Use the given point. There is a point here, 3, 1 on the ellipse, and the ellipse definition to find a. We have the distance between p and f1 plus the distance between p and f2 is equal to a. Put the numbers there, distance formula, 3 minus 1 squared, 1 plus 4 squared, etc. You will get this is square root of 29 plus square root of 29 is equal to a. Simplify the equation, you get a square root of 29. No, the eccentricity is c over a, which is 2 over the square root of 29. Rationalize, it will be 2 square root of 29 over 29 more. On this ellipse, you can see the next slide has a gift. So you can here find the center, you can find the B, you can find the equation, you can find the vertices, look at the graph. This is all extra. Question number 3, write the equation of the ellipse whose center at origin, foci on y-axis, length of minor axis is 10, and passing through the point square root of 5 to square root of 10. Make a little sketch here. We know the minor axis is 2b, so that's 10, so b will be 5. There is a point here on the ellipse, square root of 5 to square root of 5, so the equation becomes x squared over 25 plus y squared over a squared is equal to 1. Use the point here. This is the point x and y. You can replace it in the equation. So when you replace this x square root of 5, you square it, you get 5 over 25. You square this one, this is 4 times 10, so that's 40 over a squared. Take this on the other side, you will get 40 over a squared is equal to 20 over 25. So a squared will be 50. So the equation becomes x squared over 25 plus y squared over 50 is equal to 1. Question number 4 is really nice because we have to find the equation of the ellipse given the foci and the y-intercepts 0 and 6. We can make a little sketch here. The foci is minus 4, 3, and 4, 3. So the center here, you can see the center is the midpoint. See, this is f prime and f, and the center is the midpoint. We have the y-intercept here, 0 and 6. Y-intercept 0, 6, 0, 0. Now we know the ellipse is horizontal, and also the center is the midpoint of the foci, so we can use the midpoint formula. So C will be 0, 3, which is h and k. The length of the minor axis is 2b. B will be 6. So b squared will be 9. Okay. See, the minor axis here is from 0 to 6. So that's 2b. The distance between f and f prime is 2c. So you can say the distance between f prime, absolute value of a minus b, 4 minus minus 4 will be 2c, so c will be 4. C squared will be 16, or you can use the distance between the focus and the center is also c. This is another way. Now for the ellipse, we have c squared is equal to a squared minus b squared. You can use that to find a squared. We know the ellipse is horizontal. Always A is greater than B in the ellipses, and the center is 0, 3. So it will be x minus h squared, which is only x squared over 25. And then y minus 3, this is k squared divided by 9 is equal to 1. The domain now is minus 5 to 5, and the range 0 to 6. Question number 5 is interesting. Given the equation y equals minus square root of 4 minus 9x squared, all divided by 2. Let's say the domain is a to b and the range c to d. After you find that from the graph, find the value of a plus c in the bracket times the b. So don't use the d in the answer. Now, the equation is half ellipse. How do we know? Rearrange the equation, square both sides only to know what is the equation. When you square this, you get y squared, and there's a 4 here. This minus will disappear when you square it. It will be plus 4 minus 9x squared. Now take 9x squared on the other side, and then divide by 4. See, this is what you get. Now this one you have to rearrange it. 9x squared over 4 becomes x squared divided by 4 over 9. This is complete ellipse. Remember, guys, this is complete ellipse. But our equation is half ellipse because we have only y equals negative. So if you draw this ellipse here, it will be complete ellipse. But you take only y negative. Y negative means under the x-axis. That's the little trick. So let's see, the domain will be from minus 2 over 3 to 2 over 3, because you take x-intercept y0 here. And then the range becomes from minus 1 to 0 here, because that's half the ellipse. That's why in the question we don't use the d, because it will take out everything, the 0. So a plus c is minus 2 over 3 minus 1. In the bracket, multiply by the b, 2 over 3. So this becomes minus 2 minus 3 over 3. And the final answer minus 10 over 9. Question number 6. Find the eccentricity of the ellipse. Whose equation is this? 4x squared plus 9y squared minus 8x plus 36y plus 4. For sure, we have to complete the square on the x, complete the square on the y, and then find c and a. So this is the given. To complete the square, we have to go slowly, put all the x's together. So this is 4x squared minus 8x. Since the coefficient here is not 1, so I take 4 only from the x's, x squared, and there's here minus 2x. Now I take the y's, 9y squared, 36y. I need to make the leading coefficient 1. So I take 9 out, becomes here 4y plus 4 is equal to 0. Now I complete the square inside the bracket. Minus 2 divided by 2 minus 1. Square it, plus 1 minus 1. Same thing here, plus 4. 4 divided by 2, 2 square it, plus 4 minus 4. Now the first three terms becomes here complete, x minus 1 squared, and here we have y plus 2 squared. Now multiply again in the bracket, 4 times the bracket minus 4, 9 times this minus 36 plus 4. So on the next slide, you have to write everything in standard. So the 4 cancel, take 36 on the other side, divide by 36. We will get this and this and this. So we have x minus 1 squared over 9, y plus 2 squared over 4 is equal to 1. The bigger number is a, so a squared is 9 and b squared is 4. Use the formula for the ellipse. C squared is equal to a squared minus b squared, so c plus or minus square root of 5. Now the eccentricity is equal, E equals c over a. Square root of 5 divided by 3. Now let's answer the 4 parts on the next slide. This is the equation, and this is the graph. The center in the middle, f prime is inside, v and v prime. Now let's answer A, B, C, and D. The center is 1 minus 2. This is H and K. The vertices 4 minus 2 minus 2 minus 2. The foci is this. The domain, you can find x-intercept, then you add H. We have seen many examples. And the range, find the y-intercept, then you add K. These are the answers of the 6 questions. For other examples and the formulas and everything you need, please, you can visit the video pre-calculus course, lecture number 38 about ellipses. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.